Hi class, we're looking at question 53 from chapter 3, section 7. If you look at this, we have two cubes and we're calculating the volume. Remember, volume of a cube is length times width times height, or the dimension to the third power. So initially we have the 18 inches, which is the measure of the side. So if we take 18 to the third, we end up getting 5832. And that's going to be our centimeters cubed. So if we had a half an inch error, which would be 0.5 centimeters error, that would give us a side length of 18.5 centimeters, and we take that to the third power as well. When we do that, get 18.5 to the third power. We get 6,331.625. If we subtract from that the original 5832, we're left with 499.625. And then if we divide that by the original, which again was the 5832, we get the decimal of 0.08567 about, which when we multiply it by 100 to get the percent is almost 9%. Okay, so we get the 9% error for the 18-inch cube. If we go down to the 17.5, it will give us a little less than 9%. It'll give us around 8%. So we always want to take the larger to be on the safe side here. So now we look at the 45 centimeter sided cube. Okay, and again we're going to use the units are cubed, and we're going to cube the sides in order to get the volume, and then we're going to subtract the 45.5 centimeter side. Okay, and again we have to cube those to find the volume. So I'm going to do that on my calculator right now. Clear this. We have 45 to the third, and then we take 45.5 to the third, and we subtract the difference, 91125, and then we divide it by the original again, which was the 91125, and we're left with approximately, if we multiply by 100, we're left with approximately 3%. I apologize for doing a lot of that on the calculator, but it does work. Just be careful that you're cubing all of your dimensions. So then we ask ourselves, explain why using the same measuring unit did not yield the same percent error for two cubes. If you think about it, if you have something that's only an inch and you're just estimating it to an inch, you could be off by half an inch either way. That's like 50% of the one dimension. But once you get to 100 inches or even 45, that is minor in the scope of the original dimension. So that's why the smaller the unit that you're measuring, the more precise you want your dimensions to be, so that that error doesn't affect the measurement in its entirety. The next question we're going to look at is question 55. And here we have a sheet of paper that's 12 by 12 centimeters, and it's all of the sides are increased by 10%. So if we take 12 and we multiply it by 1.10, that's going to give us the additional 10%. Okay, so we're back to my calculator here, and we have 12 times 1.1 and that gives us the 13.2. So now we had a 12 by 12, okay, which is 144 square centimeters, okay, and then we take the 13.2 and we square that, and we're left with 174.24. Okay, so now we look at the difference between them. So we subtract the 144 from here, and we're left with 30.24, which we then divide by the original of 144. Again, always divide by the original, and we get 0.21, which is 21%. Now the question is, why are we always getting this 21% increase? Well, if you think about it, it all has to do with multiplying by this extra 10%. If you just assume your side is x and you multiply it by 1.10, okay, and then you end up squaring the whole thing, well, what is 1.1 squared? 1.1 squared. It's 121, which means you had the original size of 100%, and then you increased it by 10%, which actually, when you're compounding it with multiplying both sides, gives you the extra 21% increase in your area. Hope this helps. I'll see you in class tomorrow.